Imagine, if you will, a night so still and vast that the stars don't just twinkle. They whisper secrets across the endless black. You're standing on a windswept hill, far from the city's glow, your breath catching in the crisp air as you tilt your head back. There, among the familiar constellations, something stirs. Not a shooting star, fleeting and gone, but a wanderer from the void beyond our sun's gentle pull. It's called 3IATLAS, a name that rolls off the tongue like a forgotten incantation, and in the summer of 2025, it slipped into our solar system like a ghost from another dream. Discovered on July 1st by a Hubble survey telescope in Chile, it hurtled toward us at speeds that defy the lazy drift of our cosmic neighborhood, nearly twice as fast as the last interstellar guest we welcomed. In those first heart-pounding moments, astronomers felt it, a shiver of the unknown, the kind that makes your chest tighten with equal parts fear and fire. This wasn't just rock and ice tumbling through the dark. It was a messenger, perhaps, carrying echoes of worlds we'll never touch. And now, as it draws nearer, turning an eerie shade of green under the sun's relentless gaze, one question burns brighter than any star. Is this the hand of nature, wild and wondrous, or something far more deliberate, a pulse from a mind out there in the silence? Let me take you back to that electric dawn of discovery. Picture the control room at the Atlas Observatory, screens flickering like distant lightning. A team of bleary-eyed stargazers huddled over data streams that had been chugging along unattended. July 1st, 2025, a date that will etch itself into the annals of human curiosity. The alert pinged softly at first, then louder, insistent. An object, faint as a sigh, crossing the ecliptic plane at an angle so precise it felt choreographed. 3I/ATLAS, the third confirmed interstellar intruder, following the enigmatic cigar of Oumuamua in 2017 and the more demure Borisov in 2019. But where those visitors were ghosts, glimpsed for mere months before vanishing into the cosmic tide, this one lingered. It stayed visible, growing bolder, brighter, as if teasing us with its secrets. By September, as we stand here in the hush of 2025, amateur skywatchers with backyard scopes are catching glimpses of it, a hazy emerald smudge against the velvet night, shifting hues like a mood ring from the stars. It's no longer the domain of giants like Hubble. It's ours, intimate, pulling us into its orbit with a gravitational tug that feels almost personal. What makes your pulse race, though, isn't just the sight of it. It's the way it moves, elegant and improbable, threading the needle of our solar system like a dancer who's rehearsed every step. It barreled in from the interstellar deep at over 26 kilometers per second, fast enough to cross the Atlantic in under 4 minutes. Yet its path wasn't the chaotic tumble you'd expect from a rogue chunk of frozen eternity. No, it sliced in at nearly a perfect right angle to the plane where Earth and her siblings circle the sun, only to curve gracefully, brushing close to our worlds like a courteous stranger pausing for introductions. In July, it whispered past Mars, just 22 million kilometers away, near enough that the orbiters circling the red dust ball could have snapped portraits sharp as a lover's gaze, if only someone had thought to turn their lenses. NASA didn't, or so they say, but the missed chance hangs in the air like regret. Now it's arcing toward Jupiter, set for a rendezvous in November, a scant 127 million kilometers from the gas giant's swirling storms. Astronomers crunch the numbers, their faces paling under the fluorescent hum. The odds of such a tour, 2 planetary flybys in one grand sweep, are 1 in 1,000 for a random wanderer. Slender, yes, but stack that against the rest, and the improbability swells like a gathering storm. It's as if this visitor plotted its course with intention, timing its arrivals for when we'd have the clearest view. Mars at opposition in summer, Jupiter gleaming full in autumn sky. Coincidence? Or a subtle nod, an invitation to watch closer? As the weeks blurred into a frenzy of observation, the real unraveling began. Telescopes around the globe swiveled like eager eyes, but it was NASA's SPHEREX that pierced the veil. Launched with a $250 million dream, this infrared sentinel chills itself to near absolute zero, sipping the universe's hidden heat signatures like a sommelier savoring rare vintages. From August 8th to 12th, it trained its unblinking gaze on 3IATLAS, sampling every 12 hours for 5 relentless days. The data poured in, a torrent of light and shadow, and when the scientists sifted through it, their world tilted. A colossal plume of carbon dioxide erupted from the object. 70 kilograms per second, a ceaseless geyser that could choke a fleet of sedans in minutes. Imagine it. Not the misty breath of water ice surrendering to the sun's warmth, but pure, pristine COO2, billowing like smoke from a hidden forge. You'd think, heart-quickening, this is comet poetry, gases awakening, tails unfurling in solar fire. But then the absence hit like a gut punch. No water vapor, not a whisper, not even the faintest trace that SPHEREX's exquisite sensitivity, down to 5 kilograms per second, could miss. And carbon monoxide? Vanished too. Another ghost in the machine of expectation. In all the tapestry of comets we've unraveled, from Halley's fiery return to the icy harbingers of dawn, nothing like this has ever bloomed. Comets are dirty snowballs, patchwork quilts of frozen relics stitched from a dozen ices and dusts, exhaling a symphony of vapors when the sun kisses them awake. Water should steam first, a veil of fog. Carbon monoxide should tag along, sharp and inevitable. But 3IATLAS, it sings solo, a lone aria of CO2 so pure it defies the chemistry etched into our stars. The spectrum glows with that single crystalline note. No chorus, no clutter. It's as if this thing was forged in a crucible apart from our own, its heart a monolith of dry ice, untainted by the wet chaos of birth. And the isotopes, the subtle flavors of atoms, carbon and oxygen laced in ratios that whisper of origin, they don't belong. 13% richer in carbon 13 than our solar family's norm. Oxygen skewed 9% high. These aren't the echoes of supernovae we know, nor the gentle nurseries of red dwarfs. They're outliers. 8 standard deviations from the galactic mean, adrift in a sea of improbability. Avi Loeb, that Harvard sage with eyes for the extraordinary, leaned over his calculations and murmured of environments unseen, or, perhaps, processes not of nature's hand, but size. Oh, the size steals your breath next. From the heat it radiates and the light it scatters, the math conjures a behemoth, 46 kilometers across, a sprawling realm that could blanket Manhattan and spill into the boroughs beyond. Larger than cities, heavier than dreams. Borisov, our last interstellar kin, was a pebble under a kilometer. Oumuamua, a mere 200-meter shard. This, a million-fold titan, defying the scatter of stellar debris. If the void between stars teemed with such giants, we'd have netted schools of minnows first, hundreds, thousands, tripping our scopes like fireflies in the dark. Yet here it swims alone, first and foremost, a whale in an ocean of minnows. Loeb's models scream scarcity. 10,000 times too little rubble out there to birth this anomaly by chance. Ejected from some distant cradle, it would demand a cataclysm of perfect violence. Planets colliding in symphony, flinging it forth at just the right languid 5 kilometers per second. Not the frantic 20 or 30 of typical exiles. Slow, deliberate, as if braked for the journey. The measurements hold firm, cross-checked in infrared and reflected gleam. No error to blame. It's real, this colossus, and it mocks our maps of the Milky Way. Then, the light, or lack of it, twists the knife deeper. Comets don't arrive demure. They parade, trailing veils of dust that catch the sun and blaze like auroras, halos and tails painting the sky in ethereal fire. But 3IATLAS, it gleams as a pinpoint, a solitary spark amid the gas's fury, dust all but absent, 10,000 times scarcer than kin. Hubble's gaze in July caught a glow, yes, but not the expected fan-arcing sternward, bowed by solar wind's breath. No, a halo, circular and serene, blooming equidistant in every direction, with brightest blooms. Ahead. Forward, against the rush of charged particles screaming from our star at hundreds of kilometers per second. Physics recoils. Dust should flee the sun, tails trailing like comet hair in the breeze. Material leading the charge? It defies the wind, suggests forces unseen. Plasma, perhaps. Ionized whispers needing power beyond mere sunlight. A glow without source, like embers kindled in vacuum. And now, in these September nights, as it nears, that green hue blooms stronger, a verdant shift hinting at switches flipped, mechanisms humming to life. Is it awakening? Or has it always been awake, watching us watch it? The anomalies pile like storm clouds, each one a brushstroke in a portrait too strange for nature's palette, a trajectory too tidy, a composition too pure, a scale too grand, a silence where spectacle should roar. And as it hurtles toward perihelion on October 30th, 1.4 times Earth's distance from the sun, too far for the frenzy of melt, yet close enough for secrets to spill, we hold our breath. JWST peered on August 6th, 4 hours of scrutiny with instruments that could taste alien alloys, and though whispers leaked by late August of that impossible CO2 dominance, traces of water and monoxide flickering like afterthoughts, the full unveiling lingers. NASA murmurs of coordination, of verifications in the quiet corridors of power. What did they see in that verdant pulse? A natural oddity, rewriting our lore, or a craft, adrift or aimed, firing signals across the gulfs we've only dreamed? The window narrows, precious months before it arcs away, fading into the forever. But in this moment, under these stars, the wonder grips you. The ache of the possible, the thrill of the alone no more. The stars above seem to lean closer now, as if they too are straining to hear the secrets of 3IATLAS. By October of 2025, this interstellar wanderer is no longer a distant speck, a curiosity for telescope lenses alone. It's a presence, a faint emerald glow in the night sky that feels like it's watching us as much as we're watching it. Its journey through our solar system has become a story whispered in observatories and backyards alike, a tale that stirs the kind of wonder that keeps you awake long after the world has gone quiet. You can almost feel it, the weight of a mystery so vast it could rewrite not just our books, but our place in the cosmos. As it cruises past Jupiter this November, drawing within 127 million kilometers of the gas giant's churning storms, the questions multiply like constellations. Why does it move so deliberately, as if charting a map only it can read? Why does it exhale pure carbon dioxide, a chemical hymn no comet has ever sung? And why, when the James Webb Space Telescope turned its unblinking eye on it, did NASA fall silent, holding the truth like a breath they're afraid to release? Picture yourself now, standing on that same hill, the autumn chill seeping through your jacket as Jupiter blazes low in the sky. Somewhere out there, 3I/ATLAS is gliding closer, its trajectory so improbably perfect it feels like a performance. The path it's carved through our solar system isn't just unlikely, it's audacious. Back in July, it skimmed Mars, close enough for our orbiting probes to have caught its portrait in crystalline detail. Yet NASA's cameras stayed fixed on the red planet's dust. A missed chance, or perhaps a choice, one that lingers like a shadow. Now, as it arcs toward Jupiter, the timing feels orchestrated, arriving just as the planet aligns for Earth's best view, opposition season painting the giant in full splendor. The odds of such a cosmic tour, brushing two planets in one pass, are slimmer than a whisper in a storm. Less than 1 in 1,000, the simulations hum, and when you weave that into the tapestry of its other oddities, its size, its chemistry, its ghostly halo, the improbability grows heavy, almost tangible. It's as if this object chose its route, not flung blindly by some distant catastrophe, but guided, deliberate, a traveler with a purpose. That purpose, if it exists, lies hidden in its strangeness. Let's linger on that carbon dioxide plume, the one Sphere-X caught streaming at 70 kilograms per second, a torrent that could fill a small room in moments. Comets, those ancient wanderers of ice and dust, should breathe a chaotic mix of vapors when the sun's warmth stirs them. Water first, always water, steaming in clouds that birth glowing tails. Carbon monoxide next, sharp and fleeting, a companion to the thaw. But 3IATLAS defies this script. No water, not even a trace, despite Sphere-X's ability to sniff out mere whispers of it. No carbon monoxide either, just that pristine CO2, a signal so pure it's almost unnatural, like a note struck on a tuning fork in a silent void. This isn't the messy exhale of a comet's melting heart. It's surgical, refined, as if crafted in a place where the rules of our chemistry don't apply. And those isotopes, the carbon-13 richer by 13%, the oxygen skewed 9% beyond our solar norms. They tell a story of origins that don't match any star we know. Not the fiery crucibles of supernova. Not the gentle cradles of dwarf stars. These ratios sit 8 standard deviations from what nature should allow, a statistical scream that this thing wasn't born in any nursery we've mapped. Now, let's talk about its glow, or the lack of it. Comets are showy, vain things, trailing dust that catches sunlight in shimmering veils, their tails streaming like banners in the solar wind. But 3I/ATLAS, it's a ghost, a pinpoint of light with no entourage of particles. Hubble's images from July showed something, a faint halo, yes, but not the comet's classic fan, swept back by the sun's relentless push. Instead, this glow spreads evenly, a perfect circle with its brightest arcs inexplicably ahead, defying the solar wind's force. Charged particles blast from the sun at hundreds of kilometers per second, shoving dust backward, always backward. Yet here, material lingers forward, as if held by some unseen hand. Scientists murmur of plasma, of ionized gases glowing without dust, but that demands an energy source far beyond the sun's gentle heat. A battery in the void, a mechanism humming where ice should simply melt. The absence of dust, 10,000 times less than any comet should shed, only deepens the riddle. How does it spew such torrents of gas without dragging along the gritty relics of its birth? It's as if the CO2 isn't sublimating from ice at all, but born of some other process, chemical, electrical, or something we can't yet name. And then there's the size, a number so staggering it feels like a myth. 46 kilometers across, a titan that could swallow cities whole. Compare that to Borisov, a kilometer at most, or Oumuamua, a mere 200 meters long. This is 1,000,000 times their mass, a colossus that shouldn't exist in the sparse drift of interstellar flotsam. Avi Loeb's calculations paint a stark picture. The space between stars is too empty, too stingy with material, to birth such a giant and fling it our way by chance. The odds are a cosmic lottery, a 1 in 10,000 shot that we'd stumble on this whale before netting a single minnow. Its slow drift, 5 kilometers per second through the interstellar void, not the 20 or 30 of a typical exile. Hints at restraint, a journey not of chaotic ejection, but of measured departure. Perhaps it didn't travel far, born in a nearby star's shadow, or perhaps it was slowed, guided, its velocity tuned for this visit. The measurements hold, unyielding, checked by heat and light alike. This isn't a mirage, it's a mountain moving through our skies. The James Webb Space Telescope, humanity's sharpest eye, turned toward 3IATLAS on August 6, 2025, for 4 long hours. Its instruments, capable of tasting the chemical soul of distant worlds, probed with surgical precision. Near-infrared spectrographs hunted for molecular fingerprints. Mid-infrared sensors mapped heat and minerals. If anything could unmask this enigma, reveal artificial alloys, geometric scars, or the pulse of unnatural energy, it was Webb. Yet nearly 2 months later, as September's leaves turn, NASA remains silent. No data, no papers, no whispers of failure or triumph. This isn't normal. Webb's discoveries usually spill forth within weeks, shared with a world hungry for truth. The delay feels heavy, deliberate, as if what they saw demands pause, coordination, a careful script for a revelation that could shake us to our core. Other agencies, Europe's ESO, China's FAST, are watching too. Their telescopes trained, but Webb's silence casts the longest shadow. Are they verifying, debating, or staring at evidence so profound they're unsure how to speak it? As 3I/ATLAS nears its closest brush with Earth on October 30th, 265 million kilometers away, it grows brighter, its green hue deepening, like a signal gaining strength. Observatories worldwide are reserving time, their lenses hungry for detail. Radar facilities, like Arecibo's successors, are gearing up, hoping to ping its surface for shape and spin. The Juno probe, orbiting Jupiter, could pivot for a glance during the November flyby if NASA wills it. Every moment counts, for after its solar approach at 1.4 astronomical units, too distant for the fiery meltdown of comets, it will swing outward, fading into the dark by early 2027. This is our window, our fleeting chance to ask, is this a rock, however strange, or a relic of intent, a probe or monument from a mind beyond our own? The anomalies, its path, its chemistry, its silence and dust and light, form a pattern too sharp for chance. Each alone is a puzzle. Together, they're a shout. And as we stand beneath the stars, hearts racing, we feel the weight of what's at stake. A truth that could humble us, or a mystery that could haunt us forever. The night sky over your hill is colder now, the stars sharper, as if the universe itself is holding its breath. It's late October 2025, and 3I/ATLAS is at its closest to Earth, 265 million kilometers away, yet bright enough to haunt the dreams of anyone who gazes up. That emerald glow, pulsing like a heartbeat from the void, feels alive, intimate, as if it's whispering directly to you. The world is watching, from the humming domes of observatories to the quiet backyards where amateurs tilt their scopes toward the heavens. This is no longer just a scientific curiosity. It's a shared obsession, a question that tugs at the edges of our souls. Is this massive wanderer, this 46-kilometer titan, spewing pure carbon dioxide, a freak of nature's endless creativity? Or is it something more, a beacon, a relic, a deliberate signal from a mind that knows we're here? As it sails past Jupiter, its path too perfect, its chemistry too alien, the silence from NASA's James Webb Space Telescope grows louder, heavier, like a secret too vast to speak. The clock is ticking, for soon 3I/ATLAS will turn, slipping back into the interstellar dark, and we may never know if we missed our chance to greet the cosmos. Let's walk through this moment, the air sharp with autumn's bite, as 3I/ATLAS reaches its perihelion on October 30th, 1.4 times Earth's distance from the Sun. Too far for the fiery meltdown that makes comets blaze, yet close enough for its green hue to deepen. Its CO2 plume to roar at 70 kilograms per second, a relentless exhale that defies everything we thought we knew. Comets should be messy, their icy hearts melting into a chaotic spray of water, monoxide, and dust, painting tails that stretch like banners across the sky. But this? It's a ghost, a pinpoint of light with no dust to speak of, its halo a perfect circle, glowing brightest where physics says it shouldn't. That forward gleam, defying the solar wind's push, suggests something else. Plasma, perhaps, or an energy we can't name, humming from a source that isn't the sun. The isotope ratios in its CO2, skewed far beyond our galaxy's norms, whisper of origins unthinkable. Not a star's cradle, but a forge unknown, artificial, deliberate. And its size, 46 kilometers, 1,000,000 times the mass of its interstellar kin, challenges the very math of the cosmos. The void shouldn't birth such giants, not by chance, not in our lifetime. Yet here it is, a mountain adrift, moving at a leisurely 5 kilometers per second, as if it chose this pace, this path, to linger in our sight. The world's telescopes are locked on now, a global chorus of lenses and antennas straining for answers. Radar dishes, successors to Arecibo, pulse signals into the dark, hoping to map its shape, its spin, its surface. Anything to tell us if this is rock or relic. The Juno probe, circling Jupiter, could steal a glance as 3I/ATLAS sweeps by in November, if NASA dares redirect it. Every observation is a gamble against time, for by early 2027, this visitor will fade, its light dimming as it arcs back toward the stars. The trajectory alone feels like a gift, or a taunt. Its close passes by Mars and Jupiter, timed for our best view. Defy the randomness we expect of cosmic driftwood. Less than 1 in 1,000 interstellar objects would thread such a needle, brushing 2 planets in one pass, aligning with Earth's gaze at their brightest. It's as if 3I/ATLAS wanted to be seen, wanted to be studied, wanted to stir the ache of wonder in our chests. And yet, the silence from Webb's August 6th observation, 4 hours of scrutiny with instruments that could taste alien metals or map unnatural heat, hangs like a fog. NASA's reticence, now stretching into months, feels less like caution and more like a struggle to frame a truth too big for words. Imagine the scientists in their labs, faces lit by screens, arguing in hushed tones. The data from SPHEREX, from Hubble, from ground-based scopes, paints a picture that doesn't fit. The CO2's spectral lines, sharp and cold at 89 Kelvin when the surface burns at 160, suggest not sublimation, but something else. Chemical reactions, electrical discharges, or a mechanism we can't fathom. The absence of water and monoxide, the purity of that gas, the alien isotopes, it's a pattern, not a fluke. Each anomaly alone could be a quirk. Together, they're a symphony of the impossible. Avi Loeb, that Harvard dreamer who dares voice what others whisper, speaks of probabilities so vanishingly small they border on zero. The math screams, this isn't random. A natural object, born of ice and chaos, shouldn't behave this way. It shouldn't move so neatly, glow so strangely, or carry the chemical scars of a process we can't name. And yet, the alternative, a craft, a probe, a monument shaped by hands not our own, feels too vast, too terrifying, too thrilling to fully embrace. But the evidence stacks higher, each observation a brick in a wall that blocks out simpler answers. Now, as the world holds its breath, the stakes feel personal. You stand on that hill, the stars a canopy above, and you wonder, what if this is it? The moment we've dreamed of since we first looked up, the proof we're not alone. If 3IATLAS is artificial, a visitor sent or left behind, it changes everything. It means someone, somewhere, built something to cross the gulfs between stars, to linger near our worlds, to pulse green and silent under our gaze. The implications ripple outward, touching every corner of who we are. Our science, our stories, our sense of solitude in the cosmos, all shift. But if it's natural, a cosmic fluke born of some unseen crucible, it's no less profound. It means our universe is stranger than we dared imagine, capable of forging giants that defy our rules, that challenge our place in the grand design. Either way, 3I/ATLAS is a mirror, reflecting our hunger to know, our fear of what we might find, and our courage to keep looking.